CPU ID instruction, normally it takes about 200 ticks. I just execute it 1,000,000 times, average it out. And when you're running in non-root mode, it takes about 3,000 ticks. Because every time you execute it, it needs to transition into the hypervisor. It needs to execute CPU ID, set the registers for the guest, pass them back. And obviously, that takes more time. There are things you can do against this to basically make detecting latency a little more difficult. VTX supports what they call the TSC offset. So basically, whenever you can sort of erase the VM exit time by, once the VM exit happens, get the current TSC, and when you're handling the event, when you're done handling the event, get the new TSC, and just add that to the TSC offset. So basically, the time spent handling device access, handling things like that is just erased from the timestamp counter. And basically, the only thing a guest can do is there still may be some skew from this, or basically they can detect that the clock on their system is getting more skew against the real-world time than normally. OK, so now's the actual fun part. After I bored you with a bunch of details about code and instructions and all this jazz, and go to the demo. See if we can see everything here. All right. OK, so make sure I crib my notes. Yep. All right. OK, so we run. So I have like a little small program to benchmark the benchmark CPU ID. OK, it's about 167 ticks to run CPU ID. I have another program to show you the source to this. Basically, CPU ID.c just takes the argument of the command line, puts that in EAX, and runs CPU ID. So if we run, if I can read my own usage, basically, we've given any argument. It has no clue what deadbeef in EAX means. But let's actually install the thing. All right. Worked. This is the first time it's panicked there. I promise. Yeah, demos. We'll give it one chance to redeem itself. I think I didn't test it running Keynote at the same time. Is that maybe? Sure. Yeah, that's a good idea. Let's take questions while we're waiting. Yeah. We don't have to enable VMX operation in the BIOS. Oh, yeah. Sorry. He mentioned that I mentioned that I have to enable VMX in the BIOS. Did I do any research on what platforms I had to enable it on? And basically, the answer is you don't have to enable it in the BIOS. Normally, it's you can disable it in the BIOS. Like PC manufacturers can do that if they choose. But the systems, well, at least all the Macs I looked at, it's enabled by default. And I haven't heard of any PC manufacturers actually disabling it in the BIOS intentionally. Yeah, I did not report. OK. Detect display. Okay, that was a much better sign. Did you notice what happened here? Nothing. That's a good sign. That's what it looks like when it works. Okay. Okay, so that's readable and all that. All right, so now, we run our time benchmark. CPU ID is now roughly, 10 times slower. A little to the right, like there. A little to the left. Wait. Would you guys like me to change the color? Chartreuse, fuzzy navel. I like green, but we can take a vote. Okay, so now it's running. Now let's actually use it for something useful and make ourselves root. This is to demonstrate that there is nothing in my hands. I am not root at the moment. But let's see, print. Because I'm too lazy to do hex arithmetic in my mind. I'm also too lazy to type. Okay, so now we execute that, and it basically, instead of returning, hex 78, blah, 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 whatever, basically the CPU ID is a way of saying, I have, no clue what you're talking about. It returned the same value, which is how I indicate to myself that it worked. Type id, we are now root, which highlighting that is a nice way of blacking it out, so you can't really see that. But so right there, and we have our local backdoor, and that's basically what it does. Thanks. And I'll give the disclaimer that this code is totally smarmy hacker code. So I will not unload the kernel extension, because when I do, you'll see the panic screen again. So it's very much a work in progress. Let's go back to our regularly scheduled presentation for yeah, thanks. Okay, yeah, future work. Because most of the systems that support this have multiple cores, I should probably support multiple cores. But basically, time was short. I had actually billable work to do, so I didn't have time to finish all this. Do more work on hiding the VMM or the hypervisor from the host, and implement a remote access feature, which basically, because like I said, writing the device access stuff is a pain in the butt. Probably the easiest way to do that is to basically hook functions in the virtualized OS. Another thing you should check out at Joanna's talk, because she figured it out, I didn't. And for more information, well, you're not getting anything from me. But you look at the Zen 3.0 source code. They have basically a layer that does the virtualization for Intel and for AMD, and is probably the best source of documentation on this stuff. Yeah, and see Joanna's talk as well. And that is all I have. If there are any more questions, now would be the time. Yes? VMX? Oh, sorry. It boots in VMX root mode, and that's the state of the processor until you do anything with VMX. Okay. If any more questions, feel free to come up. Thank you.